Hey everybody, this is Dark Guardsman. We're back with another video. Now, I did record the tutorial for this episode where we actually implemented the attack AI, but we ran into so many difficulties with getting that implemented that I decided, you know what, we're going to kind of re-record this, and I'm going to go into a little bit different version of this because I already have the code. I'm not going to try to rewrite the code. I'm not going to pretend like I'm going to rewrite the code actively. So instead, I'm going to show you it working and kind of just explain how it works. And we're then going to just move right directly into getting the render code working, because what ended up happening is that when we got this code implemented in the previous thing, we ended up adding the necessary code. We went and dig through. I kind of explained what I was doing while I was working. I wasn't doing a great job, so that was kind of part of the reason. But we ended up implementing the when attack harm code, which still doesn't seem to be quite working, so we're going to have to hit up that later. I ended up implementing the vanilla version of the find target script. I ended up having to rewrite this because something was wrong with the vanilla script that was causing it to reset the target. And we did the range attack, which the range attack script for Minecraft is working just fine. It was literally just the target script that we were running in difficulties to. Had to rewrite that, which just made the whole episode end up running into almost an hour long, plus an additional 40 minutes past it when I had just turned the video off and just worked on it, trying to figure out what was wrong with it. So that would have been probably a horrible episode for you guys to watch. You really guys wouldn't have learned anything, so we're just going to take it from this view. So we do have this working. I have set this up to shoot snowballs because the original idea when I was setting this up is I was going to have it shoot me. That way I could test its aiming scripts and test it was aiming at the right target and everything else. But it's working. So it's pointing at the creeper, and it's basically beating the snot out of the creeper with snowballs, not actually doing any damage. But it functions. So I can place a new one, and it will also kind of, I guess, work. we're going to have to tweak it. We're going to have to mess with how it behaves and everything else, because it apparently can shoot itself with the snowballs, which is hilarious. But let's go ahead and get into the code. Let me go ahead and I'll tab out this so we don't have to hear all the audio. So how the code works is that we have to implement ranged attack mob on here. This is for this script right here, which is actually going to call a method in here, which is going to shoot the snowballs. So we have this method here. We don't have to do it this way. It's entirely optional, but in the actual code here, if we go take a look at it, it does a whole bunch of stuff. So it's got a whole bunch of variables initialized, a lot of stuff, as I've explained before with the AI stuff. There's a lot of stuff in here that really doesn't need to be in here, but is in here. So it's going to go should execute when it asked if it should execute. So basically how the AI tasks work is they have a should execute, continue executing, and then update tasks if they end up running. So this gets run to see if they should do anything whatsoever. Then continue executing gets called every time before they call update task. And then if this says yes, then this will call this method. And then if the task ends up resetting, it'll call reset task. And there's also another one that sets the task up as well. So when it comes to this, it goes should execute. It basically just asks, do we have a target? This is just provided by this other script. So we have separate scripts for this. So find target script will find our target. If we end up having a target when the script runs, and these scripts run like every 3 ticks or so. AIs don't run every single tick out of the game world. They have their own tick system to make sure they're not running every tick. And you can adjust that to make them run slower or faster depending on what you want to do. So should execute goes yeah, and this will go basically continue executing will go hey, should it execute? So it runs this one every single time anyways, and then also just checks to make sure we have a path to target. If it can't path the target, we don't run it. I might change this because I don't really care if we have a path to target to shoot the target. I just want to shoot the target. And then in update tasks, we basically make sure that we're looking at the target. We check some sensory. Can we see the target? So we don't want to be shooting at a wall. This is not too big of a deal. I may change this as well. I may change this so we can shoot through walls and stuff. It would be kind of cool. We then do some pathfinding stuff. More look at target stuff. Actually, this is the distance. I don't know why I said that was look at target. I was probably looking down here when I was talking, trying to think of what I was going to say next. Then we actually have our actual range checks and everything else. So when it does all its range checks, it'll actually then do the attack entity from range attack, which then we'll call the method that's inside of our entity, which I currently have set to the snowball attack from the snowman. Just as a testing, we can replace this with an error code very easily and get this actually working. We actually are going to have to change some code here to get this to work properly, because right now this is definitely clipping our entity. And we really need this to not clip our entity, which we have to do kind of with this right here. So we'll have to adjust that and get that so that way it's spawning a little bit further from us, so we're not shooting ourselves. What we're going to end up doing is probably using a ray trace system in the future, because we don't really need there to be an actual entity for this to work. So we'll get to that down the road. So I'll leave that there in the moment. So now the find target code, we were originally using the Mojang version. The Mojang version was a little bit more complicated than this. I actually dumbed the code down highly, which is, I don't understand why Mojang code's over complicated sometimes. But they originally had their code up here in should execute. So should execute was actually executing the code. And then start executing was actually setting the target. So I switched this around. I now only run this when we don't have a target, because what was happening is this was running every single tick. So every time the AI task ran, it was trying to find a new target. It was trying to find a new target. It was trying to find a new target. It did have a chance variable in there, so it had a system where it was only supposed to run like every so many random variable chance calls, which I guess was supposed to make it so that things like zombies and skeletons would switch targets if their target wasn't quite valid. But we don't want to have that happen. So what I set this to is that we only run this code if we need to find a target. And then if we, well, I actually need to do a setup to validate thing. So validate target is what I need to have up here. That's kind of the reason why I think Mojang had theirs, is so they didn't have to revalidate the target every single time. But we're going to revalidate the target is what we're going to end up doing. But in here, we basically try to find a target. We go, hey, inside this bounding box, which we grab off here, we just basically set this to targeting distance. Targeting distance initializes to follow distance. So whatever follow distance we have set is what distance it tries to find a target in. So I think we have this set to 15, so it's going to try to find a target in 15. We then say target area, we say we want to find anything living base, but we want to do a selector for mobs. So it's only going to find monsters. And as long as the list isn't empty, it's going to sort it by distance. So it's going to grab this. So what comes back here, it may give us back like 5 or 6 entities. It's going to try to find the closest entity. We probably will come back in here and try to find the most important entities. So we may try to target skeletons before zombies, blazes before that. So we may go through a list of entities and try to figure out what's the most harmful one to the player and try to take that one down first. And of course, this will be customizable in the future by the player. And then after that, we just grab the first one on the list, because we don't really care after that point. We just want some kind of valid entity, and we set that to the task host attack target, which will then make this no longer null. So that'll set that. That'll then allow our actual target code to run and allow it to shoot. So if we go back in here, of course, it's going to still run. So now the only thing we need to do is get this so that way this main cannon at the top here actually aims properly here. Because the body's aiming. That's being done. But we don't want the body to be aimed at the entity all the time. We don't want to have that situation. We want to kind of behave more like a skeleton. So let's go ahead and get this set up. So the aim code is going to be pretty simple. I say this loosely though, because I said that before in the previous video when I was recording this, and it ended up not being simple. So when we do the range attack is going to set our look position for us. So set look position with entity. It's going to do that whole thing, which is going to go through, and it's going to should set some variables for us. So to set a yaw and pitch, these are actually set somewhere else. Update look. Yeah, so it's going to set the rotation pitch and the rotation yaw head. See, we want to use the yaw here. This is also used by the head as well, so I don't know why that's not called head. You also have a body yaw, so we want to make sure the body is actually rotating with the yaw, and we want to make sure the head is rotating with a different rotation. So this will be done inside of our render. And you know what we're also going to do is I'm going to remove this code, because I want it to attack. So I want it to run the code so that way it's aiming, but I don't want it to be shooting the creeper and triggering the creeper to blow up, or whatever we happen to be using, like a skeleton or a zombie. Because that's going to make it a lot harder for us to check to see if it's aiming at the right target and everything else. So we want to make sure that the aim script is working. We don't want it to run a situation where we can't quite tell because maybe there's a snowball in the way, or it's being blown up or pushed around. So we want to get rid of that for the moment, because we're going to come back here and recode this anyways. And in the model is where we need to actually do this stuff. So I believe we kind of want to do it here, because this is going to give us our head position. This is going to give us our head yaw. And all we need to do is figure out what in the world in here we need to actually do. So these should be child to each other. I just got to figure out which one of these I need to rotate. The modeler told me at some point, but I guess I wasn't paying attention. So we don't care about the belt. We don't care about the battery. The battery's parented to... Oh no, it's got a child of that. Battery 1 also has a power light on it. The whole platform. I think the neck is our thing. Let's take a risk, and we're going to try to rotate the neck platform. So when we actually do this, we basically just want to make sure we're setting this every single time. So we would set rotation. I want to say Y is going to be our yaw. It's been a while since I've done this. Actually, instead of guessing this, what we can do is do like model zombie. Model zombie does all this stuff already. Although I think the head rotation is done in biped. Yeah, so this is what they do right here. They also do some multiplication here. We're going to do the same thing just to kind of keep consistent. And we're going to hope that is our head. And we're gonna test it real quick. So we're going to test each one of these model pieces. And go ahead and put a creeper down. That does seem to be behaving properly. Here we go. So that looks okay. And we want that whole entire pedestal up to be rotated. That looks proper. Now, when it comes to the pitch, we do not want the whole pedestal being pitched, because that'll do everything else. So we got to figure out what part we need to pitch. And it needs to be this piece and everything attached to it. So let me go ahead. So the neck platform's not it. So we know that much. It's not going to be our pitch point. So neck platform has got the neck joint. Where is neck at? Add platform neck. I'm going to say it's minigun body. So I'm going to say everything's, yeah, it looks like everything is child and minigun. This is why I really wish when programs like Tabula and Techni exported JSON stuff, they sorted this stuff. Like, if you're going to be childing a whole bunch of stuff to the minigun body, put all of that in one area, put a comment saying minigun body above it, like, try to get some organization going to the export there so it's easier to read, because this is a mess. This is really hard to read. And it's nobody's fault, really, but it would be one of those things that would be really cool. Anyways, let's go ahead and figure out how the pitch is done. So I think it's X is what we're going to be doing, and yeah, right here. So I didn't even have to look that long to figure this out. I'm curious why they're doing this here. I think this is a really quick way to convert from degrees to radians, I think is what you're doing. Because I think the models are done in radians, but then the actual rotation is stored in degrees. So you have to convert from 360 to 0 to 2, I think is what it is. So that should work. And we have to make sure we're setting these every single time we do this as well, so that way... Because how this kind of works is this model is shared by all entities, so there's only one model instance for everybody, but it's moved and repositioned as it needs to be. And that looks like that's working. So that is really good. I like that. And he's gonna, what is he targeting? Jumping trees like a boss. I don't know why he's targeting to the right over here for some reason. I think he's trying to path to shoot at the creeper down here, but it's not working. He's getting confused. This is where I really want to program my own Pathfinder. I don't want things being like running on the trees. You can imagine this would be like a 400-pound robot or something like that. It would be heavy. Big heavy robot, and if it's on a tree, it's gonna fall right through. But then I can say the same thing about the player. The player would be like 180 kilograms or something like that. No, I'm wrong on that one. 180 pounds? Yes. Getting confused. Let's get you knocked out of the tree here. Yeah, so that looks like it's working. So the animations and stuff, at least through the Mojang system, they're not hard. It is really simple, and I opened Discord by mistake. You just gotta go like in set rotation angle, you just gotta set stuff. And it gets more complicated the more parts you got. Like, for example, they're doing a whole bunch of arm stuff here. We're not really doing any animations, to be honest. If we really want to, we can try to spin the barrels and stuff. Let me do some time set day here. We could try to spin these barrels, but this model isn't designed for that, so we're not even going to do that. The only thing I would really like to do is maybe add some recoil to the barrels, just to have them like individually go back, but that's... I don't see that being a thing. So this is a really simplified model. The only thing I think we're going to end up doing is maybe animating the tracks. That's the only last thing we're going to do. Maybe have the antenna flick back and forth a little bit. But that should work. So I'm going to go ahead and end this here, and we'll be back in the next episode to do... I guess since we have the animation done, go ahead and get it to shoot actual bullets.